and it's, we're baking assumptions into that.
Yeah.
So when we say it's tolerable, it's no one has ever shown that the dose tested in humans doesn't lead to any pathology.
Right.
They've sort of projected what we imagine might be the tolerable dose from animal studies.
Correct, correct. And also another point that I think is critically important, if you look at Europe and you look at the European recommendations of tolerable doses, their dose is half to what our dose is in the United States. So they recommend no more than zero point 0.5 milligrams per kilograms of glyphosate per day. And why that is, they just said that that's what they believe should be the tolerable upper dose. So even within different countries, we kind of disagree on what those amounts should be. But the point being here, and what's critically important to establish, is that the glyphosate has the ability to cross into the brain, which
Yes.
no one had really shown at this phase, and also its metabolite, suggesting that it's being metabolized by mammalian species.
And I mean, one more thing that's important just to put in people's brains, I think, is just because you used a higher dose and you found it in the brain, it doesn't mean that if magically the dose crosses some threshold, it like doesn't get into the brain at all. You're going to
Right,
expect it to get into the brain in proportion to the dose that gets into your body.
right, right.
And so you guys showed, okay, at some dose, it does get into the rodent brain and its metabolite is there. So some kind of metabolism is happening. And I think you mentioned previously that metabolite itself is known to be toxic.
Yes, there's actually studies showing that AMPA itself, in the periphery body, for example, elicits inflammation, and it's very hard to degrade, right? Some of the questions that we got from our second paper, which I'll share next, were, well, why was it still present there? Why was AMPA present? What is it doing? Well, it shouldn't be in the body, and if it shouldn't be in the body, your immune system is going to try to remove it, and if it can't, guess what? You're going to have an increase in inflammatory molecules that can lead to other detrimental outcomes for other tissues.
Yeah, so your body will naturally try to remove things that are foreign to it if it detects them and if it can. And if it can't, you can just get a persistence of these molecules or an accumulation of them, and then that's going to naturally instigate chronic inflammation, which is not going to be good.
Exactly, exactly.
And you're detecting, like, it seems like that's what you're detecting in these animal models. You're detecting inflammation.
Yeah, so in the first study, what we did is we looked at pro-inflammatory cytokine TNF alpha. This is known as tumor necrosis factor alpha. Elevations of this pro-inflammatory cytokine have been tied to various cancers, to various detrimental outcomes in the peripheral body. And in the brain, usually those individuals that have neurodegenerative disorders usually see increases in TNF alpha as well. Yeah.
Mm-hmm. So it gets into these mice. The metabolite is there. Can you talk a little bit more about the time course here? Remind us, how long were you giving it to them, and how long was it persisting?
Yeah, so for this first study, we gave it for 14 days, and then after the 14 days, we went ahead and the animals were euthanized, and then we looked at the outcomes based off that. And our second study, that's the study where we actually looked at what are the long-term consequences, which we can get into that. This study was published just December of 2024, and what we did there with our team, we wanted to understand. There's a lot of kind of confusion of, can AMPA and glyphosate, be completely excreted out of your body after a given time, right? And the idea is that, well, glyphosate, since it can be metabolized, it should just be removed out of your body, excreted out through urine, no problem, right? However, there's evidence now that it can be metabolized by your gut microbiome. You have the AMPA, that's also a problem. So what happens to that AMPA, and what happens to the glyphosate itself in the periphery and in the brain? And what we also wanted to do, extend these findings, is we wanted to see whether in a model that actually has or shows Alzheimer's pathology, amyloid beta plaques and tau tangles, whether the pathology gets worse, right? So these mice are genetically engineered to develop the amyloid beta plaques and the tau pathology. Mice in general, if you just grab a wild type mice or a control mice, they don't develop the pathology that we see in humans, right? So we genetically engineer those mice to develop amyloid beta plaques and tau tangles. So we gave control mice and the Alzheimer's mice, we gave them one of three different dosages. It was either our vehicle dose. We went then down to 50 milligrams per kilograms a day, which is much lower than what our first study, the lower dose was. And then we did 500 milligrams per kilogram as well a day, because that's equivalent to the NOEL, right? The versus effect level. So we dosed them for 13 weeks. And then we said, let's take them off glyphosate completely.
Yep. Yep.
And let's see what happens 6 months
Yeah.
later.
So I guess the loose comparison here would be like, I grew up on a farm. I'm being sprayed with glyphosate for all my childhood, but then I move far away and I'm not exposed anymore. You're sort of modeling that type of situation.
Yeah, I would say you're moving away, but you're also on a full organic diet, let's
Yeah.
say,
Yeah.
right?
Okay.
Where
Okay.
glyphosate is no longer going to be introduced into your system. What did we find? We tested them behaviorally. We did a variety of different behavioral tests. We measured longevity of life. And then we also looked at a variety of neuropathological hallmarks. And then what we did is we did what's called an inflammatory panel. We
Mhm.
didn't just look at one molecule,
Whole
we
bunch.
looked at 23 of them, right?
Yeah.
In the brain and in the blood. And what we found was that while glyphosate itself was no longer present, it was, obviously excreted out. AMPA was in the brain in a dose-dependent manner.
Wow.
So the AMPA was made it to the brain, but it wasn't able to be removed from the brain.
It
And if
just persists.
it just persisted there. And if you look at the levels of amyloid beta and tau pathology in the genetically modified mice, you find that their levels go up in a dose-dependent manner.
Hmm.
You also find that the neuroinflammatory signature, the molecules, virtually all the molecules that we looked at were off the charts
Yeah.
in the brain and in the blood.
Yeah. And it really makes really good logical sense. This is a foreign substance. It's not supposed to be there. If it gets into the brain, it's probably just naturally pretty hard to remove things once they get past that barrier. You do find it there.